So in the next session, I would like to present our work with TFS and mainly in two projects, the iNet Protect project, and here we are preparing streaming telemetry POC, and the Season project where we are working with a network digital twin, which is also using TFS, and we are planning some extensions and evaluating these extensions. So presentation outline. First, I want to give a brief introduction into these two projects to get a little bit the scope and the framework that we work in, and then look into our TFS-related and planned current and planned activities, which are centered around an optical network controller for disaggregated optical networks, and we want to look in streaming telemetry and use it also to attach a digital twin to it. First of all, a brief introduction on the projects that this is mapped to, and it is from the iNet Protect project, which is here in the middle column, which is one of three sub-projects in the Celtic Next flagship project iNet, very large-scale project with a quite long runtime. So it says, yes, 1224, that's the Antelas project, which is ending. So in total, 7 countries and close to 100 partners, 500 project years, but we will only look at the project where Adtran is involved in, and that's the iNet Protect project. And iNet Protect is looking at automated resilience and secure networks for enterprise and society. And there are 3 of the core activities and work packages which are related to the work that I'm presenting here, and that's the network telemetry and intelligent control, artificial intelligence-based network automation, and demonstrations and test beds. And you will see in a few minutes why all 3 are relevant for this. But before we go into this, and what I wanted to add, I hope it is included here. So it is an Celtic Next project, which is relying on national funding from national funding institutes. And in case of the iNet Protect project, there are 4 countries being involved: Germany, Sweden, Netherlands, and Poland. Netherlands, their contribution is already finished. So right now we are still 3 countries being involved with their respective national funding authorities. The second project that I want to present is Horizon Europe Season project, self-managed sustainable high-capacity optical networks. And that looks in multiple different areas of the network: radio access network, fixed access network, metropolitan area, as well as the core network. And on top of that, you have, again, the AI and ML assistant control and orchestration, monitoring and telemetry, and the network digital twin. And you see that in the control, there's quite an overlap. And here in Season, we have dedicatedly also the digital twin activities, which we want to present here, because that is also where our current TFS contribution is targeted to. Now, I'm not sure who I assume there are multiple different use cases and user groups of TFS. So we will look in our work at disaggregated open optical transport networks. So we have a network, optical network, which is typically disaggregated into an open line system, the OLS, which is the ROADMs and the amplifiers, as well as the open terminals on the left-hand side, which is any third-party transponders or muxponders, spectral services, or colored pluggables. And according to the TIP, the Telecom Infra Project MUST architecture and reference framework, the proposed APIs towards the orchestrator and multi-domain controller is for the OLS, the ONF-TAPI, and for the devices, the OpenConfig, and that is very much in line with the previous presentation that we saw. So we have the multi-domain control with the open device and the network APIs. We have the domain controller for the optical transport network, which is typically a vendor-specific domain controller. And then we have the open line system disaggregated from the optical terminals. Secondly, what is the digital twin that we want to look at? So basically using, instantiating a virtual clone or virtual copy in the digital domain of the real optical network in order to evaluate the behavior, do some scenario analysis, generate behavioral data and test the reaction of the network, or collect the data and replay some instances which have occurred with different protocols and network scenarios to evaluate really the behavior of the network. And that is what we are working partly in Protect, mainly in Season, to set up this digital twin. This is mainly the work of Vignesh. That's why he's also listed here as the co-author of this presentation. And we want to look at closed loop automation and assessment of the different young models. So this is kind of the base information. Now, what are our interests in and activities with TFS? So what we had already done in the TeraFlow project was a contribution on network slicing and support of the TeraFlow demonstration scenarios. We are And the nice thing about TFS is that, according also to the recent white paper, it aims at following the tip-must reference architecture, which is also from Adtran, our strong goal. So looking at the tip-must reference architecture and disaggregated optical network control, this is what we want to bring in and further develop with TFS. Multi-domain orchestrator and optical network controller is the API northbound to TFS, and looking here in different transceiver configurations and evaluation of data models, ONF-TAPI and OpenConfig, but also looking at OpenROADM as maybe an alternative or supplementary activities, and streaming telemetry and the evaluation of protocols in that area with a netconf subscription or gRPC and GNMI. So what does the INET Protect reference architecture look like? And it's a multi-domain architecture. It can be a metro or two metro domains or two different vendor domains with their individual OLS domain controllers, which talk northbound to an optical SDN controller. And in INET Protect, we want to use and will use TeraFlowSDN as the optical SDN multi-domain controller. And the important thing and the novelty which INET Protect brought into this architecture is that we developed, or mainly led by HHI, the integration of a telemetry framework with data sovereignty features. So the APIs towards a telemetry framework using a data marketplace, different applications on top. That is, so the upper colorful part is what the INET Protect project is working on. And northbound from the vendors like Adtran, we are looking at the different APIs into the optical SDN control and for streaming telemetry. As the telemetry framework and the pipeline, that is mainly very, very commonly used, in my opinion, right now for optical networks. So it's a Kafka pipeline-based and Kafka broker-based pipeline using Telegraph as a sensoring and InfluxDB as the time-based database. Then we can consume and visualize the data using chronograph, or use visualizations like Grafana, and also attach some machine learning applications onto it. So we want to support various telemetry retrieval granularities, optimize the data storage, and demonstrate these ML pipelines and feeding it into our telemetry framework and marketplace. As part of this telemetry streaming and our plans to adhere to the TIP-MUST reference architecture, we proposed a TIP POC proposal, a proof of concept, in the MUST user group, and this is on, as there is not a lot of standardization activities yet and documents on telemetry streaming, we have proposed to TIP that we perform a proof of concept on the telemetry streaming, which allows the automation of partially disaggregated optic network with a systematic approach to telemetry collection and streaming, and allowing different data consumings to access the data. The initial use cases that we want to look at are light path performance monitoring, impairment validation, and network health monitoring, and looking at different multi-protocol telemetry streaming protocols of a partially disaggregated network, and to compare different approaches for telemetry, like having the opportunity to stream directly from the devices, or to go via an OLS controller and have the OLS controller only streaming northbound. So the goal is to develop and demonstrate a telemetry framework that complies with the requirements of MUST for monitoring partially disaggregated optical networks. And TIP has now more or less accepted this proposal. It's still a proposal. The planned starting time is probably still this year, and the POC should be completed until May of next year. So it's roughly within the next 6 months we want to execute this. We have already a demonstration network at HHI, and the middle colorful part is the 3 ROADMs, which are already operational and developed, and we have attached different mediators to it. Currently, and probably next week, an extension of the network will be added with an additional ring. So we have then in total 6 nodes in a meshed network environment. And we want to attach different terminals and maybe even pluggables. This is still open. In this slide, you just see the directly attached telemetry framework to the network infrastructure, which is the currently implemented state. But the next step that we are currently working on is to add the TeraFlowSDN controller as the multi-domain control with the TAPI, the network API, connected to the OLS control. And alternatively, we are using netconf API and gRPC to connect to an open terminal directly from the TeraFlowSDN controller, or also via an OLS controller. There are different options being currently discussed. Now, and the second point, and that is already, sorry, this is too much animations. Yes. So what we did already as a proof of concept in order to test also the TeraFlowSDN controller on top of our own commercial Adtran optical domain control, which is the ENC controller that's here in the middle part. So we have the ENC controller, which is connected either to real network elements, like in the network of HHI, or with a simulated network environment, the Osama simulator, which for the digital twin, this is what we use as a physical layer simulation or optical network simulation. And as a second part, as we want to look also at network multi-domain networks, we have an open ROADM network, which is modeled with NT-Sim, a very simple network simulator, which is talking northbound open ROADM. This open ROADM is integrated into an ODL-based domain controller, with Transport PCE extension. Transport PCE is collecting all the individual Open ROADM network elements into also a TAPI representation northbound. And both of these TAPI representations currently are connected to an first extended beta version of the TAPI driver, which is already available in the TeraFlow open source repository. So we have initial extensions on the TAPI implementation, but this is our first work point. We need to extend the TAPI implementation to have a real network model for either an optical channel or a digital channel control, and then also maybe extending the OpenConfig interface directly into TSN. And then we want to attach the analytics topics, either also directly via the ENC controller and TeraFlow into the analytics, or via an external analytics pipeline into this. So we are currently, and then we attach the different timelines. So this is currently planned work. This presentation was a little bit, I would say, focused on our own Adtran interest, but of course, so we are in this TIP POC work. Also, Chambers is interested to contribute as an Ein and Protect project partner. Telia is driving as the operator, which is strongly involved in TIP Must. Fraunhofer HHI is driving the telemetry streaming platform, as well as hosting the demo network. And Adtran, as a system vendor, we are providing the OLS APIs and the Open Terminal APIs. And that is all I wanted to present. So we are planning to use TFS as a multi-domain controller in the Ein and Protect project, and specifically in the TIP streaming telemetry block, as well as our own final demonstration, which has a larger scope in Ein and Protect, as well as in our season digital twin activities that we look there. We are planning to extend the TIP modules on the ONF TAPI implementation, on evaluation of optical network and device data models. So the previous presentation on the OpenConfig extensions, this is very much also what we are looking in, and streaming telemetry protocols. Always we want to be very closely aligned with the TIP Must reference architecture and requirements. And the presentation here is also to foster interest and evaluate possible collaboration activities, or alignment at least, with other TFS activities here in this ecosystem, in order to look at these different optical network control, SDN APIs, and streaming telemetry. Thank you very much.
So thanks a lot, Achim. Very interesting presentation. I don't know if there is any question in the room. Okay. Also, the mic is open, just in case anyone wants to shout something. Okay. If not, I have some questions. I have been talking with Luis, taking into consideration. Okay, we right now don't have a Kafka bus inside the TeraFlowSDN, I guess.
You don't have a Kafka? Yes, Kafka you don't. Correct.
That's something that's very interesting to consider. I think that we need to have at least we're interested in following the findings of this POC, just in case we can adopt somehow similar telemetry framework.
Yeah. So that's a very good point. We are aware of this, that the current TFS streaming telemetry bus is based on the OSM for very good reasons, but on the other hand, the Kafka-based streaming telemetry or messaging bus is very much common right now. So looking into how to integrate or how to coexist would be also I think, a very good, good task.
Yeah, also it's important also to align not only telemetry but also monitoring, for example. So you have talked a lot, you have not talked at all about Prometheus integration, but it also needs to be part of the equation somehow.
Yes.
So at least we need to consider this in the maybe for release 3 it's impossible to land anything on these topics, but for release 4 we need to have a monitoring and telemetrical framework at least aligned with what you are suggesting or aligned with what industry needs, let's say.
That one question that we always have also internally is if and how we can different options can coexist, so that you can have either a Prometheus-based monitoring or kind of database and an InfluxDB data analytics pipeline stack. So if these stacks can coexist, or if they have to adaptations and mediators being involved.
I don't have a quick a yes no answer, to be honest.
I would say it requires quite, I mean, taking the time to sit in a round table, take a whiteboard and start,
yes,
drawing things.
Maybe we need to take this action for some of the tech calls.
I think it's exactly the next thing I was willing to ask. I mean, yesterday in the plenary we were discussing about using tech calls also for partners to and contributors that are doing work in with TeraFlow to present their features, their progress, their needs. I think it would be nice that this presentation that you were giving us today, maybe we can try to find a slot for the tech calls, and maybe we can discuss this with the experts in a more technical, from a more technical point of view.
Just the slide, the single slide of the framework and TeraFlowSDN interaction,
Yes.
and then we evolve from here to a reference architecture for release 4, maybe. That's something that we need to take into consideration.